I do. Yeah. It's not amazing.
All right, guys. We're going to do our quiz review. We're going to do our quiz review, but there's one more thing I want to show you. It's in the notes packet, but it's only a few problems. So if you don't have the notes packet, just copy this down on a sheet of paper. Just want to show you this real quick. So this is on page 22, and the problem says the function is a solution to which of the following differential equations. So all we're going to do is we're going to find the y prime and y double prime that's asked of us. And we're just going to find y prime, y double prime, plug it into these equations and see which one comes out to be true. Okay, so this is a very specific type of problem that has shown up on the AP exam. It's not hard. We're just going to find each of the derivatives that's required of us. And then we're just kind of doing trial and error to see which one is actually going to work. So yeah, you guys can write down this problem here. So we're going to work on the equation y equals e to the 3x minus 5x plus 7. So if you look at answer choices A, B, C, and D, they all require information about y prime and y double prime. So I'm going to go ahead and just find what I need here. So y prime, what's y prime going to be based off of y of x? E to the 3x becomes what? Yeah, e to the 3x times 3. 5x becomes minus 5. We also need y double prime. Y double prime will just be what? Yeah, 3e to 3x times 3. The u prime is going to produce another 3, which will come out with this 3 here. So 9e to the 3x. So now we're just plugging into each of these choices to see which one is actually going to come out to be true. So if I try the first one here, y double prime, so that'd be 9e to the 3x minus 3 times y prime. We're just trying to see if this actually ends up giving us the right answer. And this one does, because 9e to 3x minus 9e to 3x will give us 0. Negative 3 times negative 5 is 15. 15 minus 15 is 0. So this one works. We don't have to go through the other options. Right? So all we're doing for these problems, find the derivatives that's asked of you, and then plug into the answer choices to see which one comes out correct. Okay, so we're going to see some of that in our quiz review. But any questions with this process? All right, let's begin our quiz review that you just picked up. Hey, this looks like a related race problem, but all we're doing here is mainly just solving differential equation portion of it. So let's look at them. So there's actually a little bit of related rates here, but it's just with cylinders. All right, so we have a cylindrical container with a radius of 3 inches. H is the depth of the soda in the container. where h is a function of time t. The volume is changing at a rate of negative pi over 2 root h. So we can set that aside. We know that we're just gathering information here, dv dt. Given that h equals 9 at the start of first period, solve the differential equation dh dt for h as a function of t. Okay, so we're going to find dh dt. And then once we get that dh dt figured out, we can solve the differential equation, go through our process of separating variables, and work our way to solve for h. But okay, so we know we're going to do a little bit of related rates here at the very beginning. Volume equals pi r squared h. We know that if we want to find the derivative for related rates, we know that the radius is never going to change, so that's going to make this process easier. So replace r with what? 3. Okay. Okay, so let's get our dh dt to show up by finding the derivative. V becomes dv over dt. 9 pi stays, and h becomes dh over dt. We can replace dv dt with negative pi over 2 root h. Okay, so we're basically just going to solve this differential equation. We're going to work our way towards grouping our h's together on the left, everything else on the right. And then when we solve the differential equation, we're going to be able to get it all the way up to h. So basically, we're just getting from our derivative back up to our function level. So our first step is cross multiply. Going to get all my terms to be nicely located between either numerator or denominator. Okay, so first thing, I'm going to cross multiply. I'm going to get my dh and dt lined up. So my first step is always trying to get that dh and dt in their right locations, and then I can work everything else around it. So we have those two in place, and we want to try to get h's together on the left and everything else on the right. So what do you see is out of place? Yeah, that root h, right? So what can we do with that root h? Divide it. Okay, so that's going to come over to the left. We can cancel out the pi's. And we don't have to move this, but I like to go ahead and move it just to get it out of the way. What else can we move? 18. Okay, so I'm going to move that 18 over. If you don't do it until later, it's fine, but I just like to have that left side as bare minimal as possible, because eventually we only want h on the left. Okay, so I'm going to just divide both at the same time, get them both to the denominators. So we have full separation of variables. Remember, the right side is in terms of time, t. The left side is in terms of h. So we can do power rule on the right side for sure. What rule do we use on the left side? Is it natural log? It's power rule. Okay. Why is it not natural log? Yeah, if it was dh over h, the first power, then that would be natural log, right? But if it's any other power, we got to force it to come up. We got to go through power rule. Okay. So. Okay, so I have both sides set up where the next step can be power rule. So. So once we applied our antiderivative, we're done with the calculus, and then we only have two things left to do: solve for h, and then solve for c. You can solve for h or c in any order that you want. Typically, I like to wait until my equation gets a little cleaner before I solve for c. So divided by 1/2, the same thing as multiplying by 2. So I'm just going to wait. I'm going to solve for h until I feel like I have an easy place for me to solve for c. So divided by 2, I'm going to divide by 2 first. I'll multiply by 1/2. Square both sides. So I'm going to wait till here to solve for c. My order pair to help me solve for c is, I know that h of 0 is equal to 9. So at time equals 0, my height is 9. So it's going to. So c squared equals 9, c equals 3. I'm going to go ahead and update my h equation with my c resolved. All right, number 2. The rate at which baby koala bear gains weight is proportional to the difference between its adult weight and its current weight. At t equals 0, the bear weighs initially 2 pounds. B of t is the weight of the bear. And when it's first weighed, this is our differential equation. We're just trying to find B of t. So just like before, time is the independent variable. We'll treat time as our x, and B is kind of like our y. So we're going to eventually group all of our B's together on the left and everything related to t on the right. So I'm going to go ahead and work on cross multiplying, trying to get the dB and dt lined up. All right, we see dB and dt are in their right places, but we have a few things out of place. The 20 minus b needs to come over to the left, and I'm also going to go ahead and move that 4 over to the right. So I'm going to make both swap places, and they're both going to end up in the denominator on the other side. Okay, now we have full separation of variables. Right side is power rule, left side, we have to go through a little bit of what? Your substitution, your U value is 20 minus B, but eventually what rule are we going to use on the left side? Natural log, yeah. So now there will be natural log, it end up being 1 over U to the first power. So this is natural log, yeah. Right, so we'll go through use substitution on the left so we can see what needs to be kept as part of our process. So that whole process on the left side is going to end up giving us -1 over U du, which ends up being natural log of U with a negative out in front. And that negative is going to have to stay with my natural log of U. Okay, so we have two things left to do, solve for B and solve for C. I'm going to wait to solve for C. So I'm going to work on trying to get that B by itself first. So that negative is kind of getting in the way. We do want to involve E and natural log to cancel out, but let's move that negative out of the way first. All right, so now this left side is a little bit cleaner. We can involve E and natural log to get that canceling out that we want. Let's separate that E to the exponent added together to be the product of two bases, because we know that E to the C can clean up to be just one big C value for us.
You have to show that step.
No, yeah, you can jump directly to C. You can skip that step. Mm-hmm. Drop the absolute value. We know C is already taken care of plus or minus values, so we can just drop that plus or minus. Let C take that in. Okay, solve for B. All right, I have my dependent variable solved for, and now I'm gonna do my final step here, plug in my order pair so I can solve for C. So at time t equals 0, the weight is 2, so we can use that to solve for C. right, number 3. Consider the differential equation dy dx equals e to the y times 4x minus 1. Let y equals f of x be the particular solution to the differential equation that passes through 2, 0. Write an equation for the line tangent. Use tangent line to approximate f of 2.2. So part A is a little bit of a review from previous unit. This is linear approximation. And linear approximation, our initial goal is building the tangent line equation. And once we get that tangent line equation out of the way, we can plug in that 2.2 to get the decimal. So part A, we're not going to solve the differential equation. We're just going to use this to find our slope. And so part A won't take a lot of space. Part B will take a little bit more space. So if you want to just kind of conserve the space for part A, as you may need a little bit more space to when you solve part B. So gather your order pair. You already have that. Get your slope. Okay, so once I have my tangent line equation, I can plug that 2.2 in to get my approximation. Okay, so part A is just review from her previous units, linear approximation. So get the slope from your derivative. Take the order pair that's given to you. Build your tangent line equation. And then your final step is plug in the decimal into your linear equation. All right, so part B is where we're going to go through our solving differential equation. We're going to go through our process, separating our variables. X is on the right, Y is on the left. Start by cross multiplying. Don't resolve the parentheses. The parentheses is there to help you make sure that the 4x minus 1 stays together. All right, so when I cross multiply, I have dy and dx's lined up. We do have something out of place though. What needs to be moved? E to the y. Okay. Right side is just power rule for both these terms individually. But dy over e to the y, what rule are we going to try to target with that left side? Not natural log. What rule is available for us? Okay. But what are we trying to move towards? Yeah, e to the u, right. So this the best fit for this problem is e to the u du, which is just e to the u plus c. But if we want to do e to the u, where does this e to the y have to be? Numerator, yeah. So we first want to bring that exponential function up to the numerator so that we can get it in the right location, and then use substitution can take care of the rest. So if we can write it as e to the negative y dy, then we can kind of move towards this e to the u du, and that's going to help guide us to know that, okay, our u value has to be the negative y if we want to make this turn into that setup. Okay, so e to the u just becomes e to the u. There's going to be a negative 1 that's going to stay. And then power rule on the right side. I'll multiply the negative through. So I'm going to choose to solve for c at this point before the natural log shows up. So I'm going to plug in the 2 in for x and 0 in for y, just so I can get that c out of the way. And then my final step is to eventually work in that natural log and solve for y. Okay, so I found my c value to be 7. So, all right, so I'll take the natural log of both sides, allow that negative y to drop. Negative y comes down, natural log of e goes away. And then move the negative over to the right side, and we have our equation. All right, page 2. Let's practice some problems with exponential growth and decay. So we're going to skip the first part. You guys, I'll have you guys do that for homework. Let's go down to the bottom of page 2. Let's look at 5, and then we can try 6 as well. Page 2. All right, during a certain epidemic, the number of people that are infected at any time increases at a rate. proportional to the number of people that are infected. So let's say P prime represents the rate at which people are infected. And this is always going to set up P prime equals KP. We're directly proportional to the number of people who are infected. So this form allows us to know that this differential equation is always going to end up giving us the same general equation. So we know that this differential equation, which will lead us to this. And we're just, a lot of it is just algebraic steps here, or doing substitutions, solving for C, solving for K, and then making our final prediction. So I like to organize with a set of order pairs. Remember, time is always your independent variable, and the other variable is your dependent. So if 500 people were infected when the epidemic is first discovered, and then 800 people are infected 5 days later, how many people are infected 10 days after the epidemic? So I like to always involve 0 for T, and the earliest possible time in the problem will be time 0. So we know that at time 0, 500 people. 5 days later, it's another order pair we can create. 5 days later, 800 people. And then 10 days later, we're trying to figure out after, this is one that's more straightforward. The first order pair will help you get to your C value. Second order pair will get you to your K. And then your last, and then once you have your updated equation, you can use the general or specific solution to help you make that prediction for the number of people infected 10 days later. Okay, so I can start off with my initial order pair, plug in, see if I can solve for C. Once you have a value figured out, you're going to update your general equation with that updated information, and then continue using more order pair to move forward. So my C value is 500. Now I'm going to take in my second order pair, and this should help me solve for my K value. Okay, so my goal is to solve for K, but to solve for K, I would like to get that e to the 5K by itself. So I'll divide both sides by 500. Okay, so to solve for K, I would like to bring that exponent down, but to do that, we can introduce natural log to help us move that K down. We know natural log of E just becomes 1. And so I'm going to divide both sides by 5 to get K by itself. Divided by 5 is the same thing as multiplied by 1/5. Hold on to your K value, so don't get a decimal at this point. We'll do a decimal at the very end of the problem, but if you do a decimal halfway through the problem, it decreases your accuracy. So now let's write our specific equation. Now we can use our specific solution to make our final prediction. Plug 10 in for T, and we can figure out the population according to this model. And the rest can just go into your calculator.
The quiz calculator active.
I'm sorry.
Is the quiz calculator?
Yeah, that's right. You get to use your calculator on the quiz. Okay, let's try number 7. We can save this for later. So go to the next page. All right, so start number 7, see how far you can get, and I'll follow up with the steps. So page 3. All right, so we don't know how much substance there is at the beginning, so we can just call that C, but we do know that 300 years later, whatever amount that we start off is going to decrease by half. The first order pair is not going to help us get anywhere, so let's move on to the second one. The C's will conveniently cancel out. And then we can just work our way to solve for K, and that will be our goal. Okay, next up, let's create our slope fields across the order pair, the points that are indicated. So all we do is identify the location of the order pair, plug into a differential equation, translate that number into a slope value, and then just do a slope segment through that point. It'll either be a positive slope, negative slope, slope 0, or undefined slope. If we get undefined slope, what do we do? Yeah, don't do any line, no vertical line. We just leave that space empty. So try number 8. So this order pair is negative 1, 1. So negative 1 in for x, negative 1 in for y. I'm going to get 1 over negative 1, which is negative 1. So I'm just going to interpret that with a negative slope. All of these order pairs on the x-axis, that's a y value of 0. So when y is 0, 0 over non-zero will be 0. So we do want a horizontal slope at each of these points. Okay, we're not going to finish this, but go ahead and start part B. We're going to solve the differential equation, so cross multiply, and then eventually you're going to work towards getting your y's on the left and x's on the right. So your quiz on Friday will just be these topics: solving differential equation, these exponential growth functions, slope fields, and then verifying differential equations. So we're just kind of circling around these topics. Help session tomorrow morning, 7:30. Help session Friday morning as well. And then tomorrow, we're going to continue working through this, but I do want to start a little bit with the next unit with area volume, just a little bit, but second half of class, we'll continue reviewing. Okay, and your homework is to finish pages 1 through 4. So we got through a good chunk of that. We just have a couple of pages to finish up. So pages 1 through 4, I'll send a reminder this afternoon, and I'll send you guys a link to the key where you can check your answers as well. Yeah. Okay. Have a great day, guys. Yeah.
And I see her like walk in, like her two little kid, she's like, oh, like. Oh, it's awesome.
Oh, yeah.